Welcome back, everybody. So I'm going to continue in a moment talking about the three typical layers that you have in a website. Before I do that, I still want to ask you something, just so I get a general understanding. So I would like you to just try to evaluate yourself based on what we've seen in database design theory. So if you look at all these statements and say whether you believe you can do it or cannot quite do it, just to give me an impression. And based on that, I can see if we can re-explain or make it absolutely clear, or I can redirect you to exercises. So take them one by one and think if this is something you can do. For example, if somebody gives you a table, can you tell me if a functional dependency applies to it or not? If I give you a functional dependency, are you able to spot functional dependencies? That's the first one. The second one is, if somebody gives you a list of functional dependencies, can you tell whether a set of attributes is a super key or not a super key? Can you tell that? The third one, if somebody gives you a list of functional dependencies, can you tell whether a set of attributes is a candidate key by trying to remove attributes? Can you tell if a table is in the first normal form, right? It's this atomic integrity, whether you have nested structures or not. Can you tell if a table is in the Boyce code normal form if somebody gives you the functional dependencies, right? Not just the table, but also the functional dependencies. Can you tell, right? By looking at what's on the left of the functional dependencies. Then, if somebody gives you a set of functional dependencies and a set of attributes, can you compute the closure of that set of attributes? We've done it last week on a quiz. Everybody was correct about this. Then, if somebody gives you a set of functional dependencies, can you clean it up? You know, compute a minimal basis by simplifying it, following the rules. Then if somebody gives you a table and a functional dependency and the left-hand side is not a super key, breaking the Boyce code normal form, can you decompose it into tables that are in the Boyce code normal form? And then can you use the chase algorithm? So if I give you any decomposition, maybe one that was done based on a functional dependency breaking the Boyce code normal form, maybe not, can you use the chase algorithm to tell me yes or no, the join gives me back the original table? Can you use the chase algorithm for that? That's what we call lossless, if the join gives you back the original table. Do we have one more at the end? No, that was the last one. Just wanted to get a concrete impression of where you are. It actually looks good. So you see, it's impressive all the things you can do. And again, there's plenty of exercises and past exams that make you practice this. So let me look. So functional dependencies seems like everybody. That's really, really, really good. Super keys, most of you can spot them, 85%. The candidate keys, slightly less, but 3/4 of you can spot the candidate keys, right? Trying to remove attributes. First normal form, 3/4. Remember the first normal form? All you need to see is, do we have anything nested in the cells, right? If you have no nested tables, no nested structure, then that's the first normal form. That's something you can just spot just by looking at it, almost, right? That's the first normal form. Just means you only have atomic values in the cells. Then detecting the Boyce code normal form, 1/3 of you is able to do that yet. So maybe that's something you can practice a little bit. You really need to look at the functional dependencies. Do you ever have something that's not a super key on the left? And that's the way you can tell, right? If somebody gives you a set of functional dependencies, so the set of attributes, 3/4 of you can compute the closure. So that's good. Remember that 100% of you got it right last week, this one, the closure of a set of attributes. All of you got it right. So I'm actually surprised on this one that not more of you were confident about yourself on this. The minimal basis, okay, so we have 4 in 5, 80%. And then, of course, the recent things that we learned today, so this is more fresh. Almost half of you can decompose the tables. That's already not bad. And again, you can train on the exercises. And the chase algorithm, that is probably the most difficult one. 1/3 of you can use it. All right. So this is very good. This is very good. And you'll have the exercises to continue to practice. Okay. I just had to do it. I mean, when you teach, it's very important that you get an impression of whether the knowledge actually came through. All right. Now I'm going to come back to my slides. Right here. And I assume you can download the slides now, right? Because normally I fix the link. So it seems to be the case in the Zoom chat. Somebody in the room also tried to. Who was it? Can you confirm? You got them? Okay, awesome. So I told you roughly, yes, so the kind of people who use the databases, we really have the people sitting in front of their notebooks who type the SQL queries, like you in the exercises. We have people that only use UIs, right? Typically in customer relationship, in call centers, they have these things. And then again, in the company, we have plenty of machines all over the place and plenty of people, some people on the administrative side, some people structuring the schemas because they know their normal forms. And then we have the power users programming this. And in fact, that brings us to the typical architecture of a website. What do I mean with website? I mean Digitech Galaxus, Copat Home, Aurel Fusli. I mean, just nobody's jealous if I'm citing plenty of brands, Amazon. So all of these websites, they all run like this, all of them. For you as a user, it might seem easy, right? You just open your browser, give the address, and then you browse on the website and place your orders, and that's it. But that's what's happening in the background. We have plenty of servers that actually give you these pages. And at the end, of course, you want something to be delivered to your mailbox, right? How does that even happen? So I'm going to go through this and explain to you the details. I'm going to start with the web servers. So the web servers, these are the ones that your browser is actually connecting to when you go there. So you're sitting in front of your computer, you type www.whatever.com in your browser, and then the page displays some fancy HTML page. Maybe you can log in and so on. But actually, what happens when you type the address is that your computer is initiating a connection with the server. So first, it has a way, given the Amazon.com, of finding out what IP address that is. That's called a DNS lookup, domain name server. That's how you know that Amazon.com is a specific IP address. Then it's connecting via the HTTP protocol to that IP address, sending you a request. I'm not showing you the request. It's some computery kind of stuff that contains the URL of the page that you're looking for and so on. And so there is a server on the other side, probably in a data center or something, right? And so that server takes your request. It might communicate with other computers somewhere, but once it's done, it's going to give you back 3 things. First, an HTML page. That's what's going to appear in your browser window. Then the images, because the images, they also need to be served separately. I mean, of course, they will just appear on the web page, but actually they are sent over separately from the actual HTML page. And then some additional data, CSS for the page to look good. JavaScript for the page to be dynamic. Yeah, when you click on things, then stuff happens. That's JavaScript typically. Who heard about these things? HTML, CSS, JavaScript. Who hears that for the first time? Not many of you, right? So these are just technologies that are used. All right. So again, HTML, that's the formatting of the page. CSS is to make the page look good. And JavaScript is to make the page dynamic. I heard once somebody was joking with the sort of compliments you can make to people, like you're the CSS to my HTML, right? So CSS is really enhancing the page. All right, but all of that is delivered by the server to the client, and that happens. All right, so that is called a web server. And you have plenty of technologies that do that, but this is the first contact with the data center. All right, examples of that are Apache Tomcat. Who already used Apache Tomcat? Maybe it's less popular than it used to be. Java EE, maybe. That's really the brute force way of setting up a web server. All right, it's Java Enterprise Edition. Okay, but these are some of the ways you can actually have servers. All right. So that's the web server, right? That delivers the HTML pages, the image, and so on. So now let's go to the application server. They are behind, so a bit more hidden from the users. So what happens is that the web server, the one that delivers the nice pages and the pictures and the CSS, in order to build the page, it needs information. Remember, when you go to Digitech Galaxus and you put the name of a product in there, you have a list of products that appear. They were not made up. It's not like ChatGPT generating random products, right? No. In fact, it's connecting to some other servers to try to execute the search and find the products, right? And ultimately, it's going to be a relational database. So what happens is the web server receives the request for some search on, let's say, televisions. It's going to connect to some other computers. That's from the second level tier, the application tier. And that computer contains typically Java codes, PHP codes, and so on. And the application tier is then going to connect with SQL, is going to create a SQL query. For example, select star from products where kind equals television, right? That's some SQL query you can do from the database tier. The database tier will reply with a table. That's PostgreSQL, by the way, probably here, replies with a table. The application tier is going to read the results of that table. So it's going to take the table, but you're not going to give the table to the end user, right? That would be scary to people if all you give them is a relational table. No. You need to format that nicely with HTML and CSS and so on. And this is why you use Java for that typically, or Python or whatever other language you have. So you're going to take the relational table and format it nicely as a list of products with the picture on the left and the price and the discount and so on. And then you're going to send back this information to the web server, sending back HTML, right? So the application tier in the middle has the one that has all of the complex code that takes the relational data and turns it into HTML, okay? And then finally, the database servers, well, that's the easy part because we've been working on that since the beginning of the semester. That's PostgreSQL, right? So these are the computers running PostgreSQL. And in fact, so of course, in your case, you only had a few tables. For the exam, you have a few tables, but in a company, you might have thousands of tables. So there's, of course, a bit of organization in there that the tables are grouped into something that's called a schema. And then the schemas can be grouped into something called a database, and then the databases can be grouped in clusters. So you see there is a lot of hierarchy in the way that you organize your tables. I have no idea why they call that schema, by the way, a group of tables, because until now, what we call schema when we teach databases is the attributes and the types, right? But for some reason, they also use the word schema for a group of tables, right? Again, in the exam, all the tables are in the same schema, so you don't even have to worry about these things, right? All I'm saying is that in a big company, you need a bit of organization to keep the overview of your tables. And so typically, when you have this select from, after the from, all you put is a string, right? It's the name of the table. But in general, if you have something as complex as that, then you have to specify the database, the schema, the table, right? If you don't specify the database, then it's a default database. If you don't specify the schema, then it's just the default schema. And in fact, in the exercises, this is what you're doing. You're just using the name of the table and that's it, right? But in enterprise code, you might actually find this to reference the tables, how they are grouped. By default, I think the default database is called Postgres and the default schema is called public. But again, you don't even have to type that in the Jupyter notebooks. Okay, so now what happens with the communication between the application tier and the database tier? So technically, the database tier, that's PostgreSQL, it's a server because it serves the answers to the SQL requests. And the client is whoever is connecting to that server, right? So in the exercises, the client is you, the Jupyter notebook. In a company, the client is going to be the Java program, right, who connects and creates SQL queries. And so what happens is that you have something called a session going on between the client and the server. And the session consists of, here's a SQL query, give me the results back. That's pretty much what it's about. And then you have a constant flow of SQL here, table there, SQL here, table there, SQL here, table there, the whole time, millions of times or billions of times every day. It's really just, here's a SQL query, give me a table. So that's called a session. So obviously, in many cases, you're not going to reconnect every time. You just keep the connection open, right? So, and then you just exchange the SQL against the tables over the connection. All right. Now, the way we've been doing that in the exercises is pretty simple. You just directly write your SQL in the notebook, click on a button and get the table back, right? But that's so that you understand how it works. In practice, it's a bit more complicated than that. All I want to give you is a general impression, right? We are not going to really do this, but just so you know. So the first one is the one that you already know. You type SQL, you get a table. The second one is, how do you get Java or Python to create the SQL query and get the tables back? So I will show you a bit of how it looks like. And there is a third way that kind of circumvents SQL that's called an API. It's just a programming interface based on tables or on data frames. Who heard of Pandas? Right, so Pandas is one of the ways that you can do a lower level than SQL, right? And that also exists. Now, I have to warn you that what I'm about to show you might scare you. And there's a reason for that. It's because there is what we call an impedance mismatch. These are just completely different worlds. If you look at Java and SQL, they have nothing to do with each other. In SQL, that you know, we've covered it during weeks. There's the notion of values, of tables, of rows, of columns, of attributes, of projection, selection, join, sort, grouping. All of that you know. Who knows that? All of you, right? We've spent weeks on that. So that's the world of SQL. And then there is the world of object-oriented programming like Java, PHP, Python, and so on. It's a completely different world. So here we have string integers. We might have pointers in C++, objects, arrays, assignments, loops, branches, and so on. Some of you might have exposure to that. If you had programming classes, you might know a little bit of that, but it feels very different from SQL. So how do we get them to connect? How do we make them work together? Actually, it's not trivial at all. And there are really a lot of companies specializing in that, especially in the 80s and 90s. There was a whole buzz about connecting object-oriented programming to databases and so on. Companies were making millions of dollars with these things, probably because they're solving an actual problem that people have. So the idea is that in this programming language, it's object-oriented, so you prepare what's called the statement. You might bind some parameters, then you execute it, and then you process the results, again, with object-oriented programming. So there is some connectivity between the two. It's called a driver. A driver is the software you install for the printer to work, or for the scanner to work, or even for the mouse or the keyboard to work. These days, it just works, right? We don't even install drivers anymore because it's already in the machine. But back then, when I was younger, you needed to actually download and install the drivers every time you connected something to your machine, right? And so here it's a bit the same. If you want to connect to PostgreSQL via Java, you need a driver. You need a piece of software that connects you. It's called Java Database Connectivity, JDBC, if you look at the abbreviation. So if you hear JDBC, it's just the library that allows you to connect Java to a relational database. It doesn't have to be PostgreSQL, it can also be any other SQL database. Now, I warned you it's going to be scary, but since you don't have to learn this, it's okay. You can just forget about this. It's just so you see what it looks like. So in that case, it's a language C. And so what some people do is that they kind of extend the language, C or Java or whatever, and squeeze SQL in it. So the one part that probably doesn't scare you is the one that is showed in bold, like select from where, that you recognize, right? But this select from where is just put in the middle of C code, right? So it's an extension to the programming language that allows you to do that. So in that case, we say that we directly embedded SQL inside a C program. That's the same thing with Java, right? So now you see the select from where parts, that's the part you're not scared, right? So that's SQL. But you see that what's happening is that there is some Java. You probably, for those who know Java, the private static probably feels like Java to you. So this is actually Java. And you see right in the middle of Java, we have some SQL. That's it, right? And in fact, this is how we can integrate SQL into Java. Personally, I'm very scared of this. I mean, just looking at this, all the combining of different languages and all the special characters and the squares and the curly braces and so on, I'm almost horrified by this, right? But this is fortunately, there are even other solutions that integrate into a single language, right? But basically, we have to do it. Some people call it glue. This is kind of the glue between Java and SQL. And it is, again, because of this, that we need that glue, and that it looks a bit scary, right? But anyway, you manage in the same file to squeeze some SQL inside of your Java or C program, right? Now, this is the scary one because it's actually written right in the middle. There is a less scary way that is a bit easier to understand, that is more dynamic, where you actually put the SQL query in a string with the quotes. So you select from where you put in a quote, and then you pass that string to some methods, to some function that you call, that's going to execute the query. So this one is probably a bit easier to understand, right? So you put your SQL in a string. Before you're able to do that, you need to connect. And so what you need to be aware of, but you probably already saw it in the Jupyter notebook, there's the notion of a connection string. The connection string is just a piece of information that tells you where your database is, what the name of the database is, what your username is, and what your password is to be authorized to access the database. So you might find at some places things that look like this, where you have PostgreSQL, and it looks like an address in your browser, the name of the server and the name of the database. And then you put the user or the password. In fact, you can also put the user and the passwords like this in a URL, right? So this is called the connection string. And again, you probably will see it in your Jupyter notebook. Who remembers seeing something like that in Jupyter? On the first cell normally. This is the information to connect, right? So it's the same in Java. You would also put that cell right there. And so the idea, do we have a question?
Also integrate a string inside the string so that I can.
Oh, yes, absolutely. If you do, if you put like, for example, you might want here to have some string in there. There's two solutions. Solution one is you use single quotes. If you use single quotes for your string in SQL, then it will not cause any problem with the double quotes of the overall string. Another way is to escape your string. So if you need a string, you can use a backslash character. Who already saw this kind of escaping? In many programming, you put a backslash in front of the quote, and that distinguishes the quotes from the outer ones, the one all on the left and all on the right. If you want to nest a quote, you put a backslash in front. So there are ways to basically do this. All right, but it's still cumbersome, right? It's not necessarily pleasant to do, and so this is why an integration with a unique language might be easier. All right? Okay. So what happens now is that once I have done my paperwork with the connection string, I can call create statements and then execute query passing my SQL as a string, right? And then I get a result set. There is another way where I pass the SQL query first to the statement, and then I repeatedly call execute query. It allows me to execute the same query multiple times, right? So I have these two ways of doing that. So that's where you pass it to execute query. It looks like this, and you get a result set. And again, the other solution, if you pass it earlier, it's to execute it multiple times. So here you just put the query once, and then maybe every second or every minute or every hour, you just keep executing this execute query. Maybe the data changed because somebody else modified it, but you don't need to put the SQL query again. So that's the advantage. So either like this or like that. Now, what do we do with that result set? Because that result set basically contains the table, right? The one that you see in Jupyter notebooks, you see a nice table, but in Java, of course, it needs to be passed as an object because that's an object language. So we have that table, result set, and for convenience, I'm displaying it right here. Hypothetically, this is the table we have. But in Java or Python, all you have is some variable that contains that. So how do you see what's in the table when you need to call a few functions for that, a few methods? The next method iterates through the rows. Every time you call next, you go to the next row. So you're going to first be on the Einstein row, then you call next, you're going to be on the Mirza-Kani row, and then you call next, and you're going to be on the Turing row. Then you call next, and then you're going to just notice that it's the end, right? So at the beginning, you're there, you're basically pointing to the first row, and then you have some function that says, now that you're here on the first row, get string 1. So in that case, you're saying the first attribute, that is name, what is that string that's going to return Einstein? Then you might wonder what the year is, then you just say get int 2, and that gives you 1909, and then get int 3, that gets you 1. Now you see, what's not great is that you use indices, right? It would be nicer to use the columns, the names of the columns, but in that case, there is, because it's object-oriented programming, you have this API that forces you to know the order of the columns, right? So it's not optimal, but it does the trick. It takes care of it, and you can get inside these variables in Java or Python, you get Einstein 1909 1. Then you call next, that goes to the second one, and you can again call get string 1, then you get Mirza-Kani, then get int 2, then get 2014. That's the Fields Medal year, and get int 3 gets you 2. All right. Now, what do you do with that? They go into the HTML. Because again, remember, you want to create an HTML page. So all of these variables here that you're extracting from the table, they go into the HTML page that you will show the user. So in fact, what typically happens in a program is that you have what's called a while loop. A while loop, who knows what a while loop is? So a while loop is a way of repeating and repeating and repeating and repeating and repeating and repeating and repeating all over until some condition stops being true. So in that case, while we find the next row, we keep repeating and repeating. We go row by row by row, maybe 1,000,000 times. And for every row, that's what you have inside, we get the name, we get the year, we get the ID. And we repeat, 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 repeat. And then at some point, next will return false because we're out of rows, and then it stops, right? And typically what you do is that you append some HTML to the page as you go to create what the user sees, all right? Now you can also update the database like this, right? So you, instead of execute query, you have execute update and this insert into blah, blah, blah. So typically when a customer places an order, that's what you do. You will insert the order into the database. When somebody creates an account, you insert a new record in the list of your users, right? So this is how it all happens in Java. Oh, this is very dangerous, but you can also, delete tables and so on. In fact, it's an opportunity for me to remind you that this is a security risk. Who heard of SQL injection attacks? Okay, this is very dangerous. And in fact, it happens when you build the string here, concatenating from some input that the user put on a web page. But then, in some cases, there is a way that on the web page, you can trick the system. For example, if you ask here for the values to insert, and foo is input by the user, what the user could put inside the form on the page is foo, and then closing the quote parenthesis semicolon, and then delete star from everything. That's called the SQL injection attack. So you need to be very careful if you use string and you build your strings from input that your users on the web page provide. Be very, very, very careful. Something to be aware of. Okay. All right, so a better way to avoid this is to use question marks like this, where you put a question mark and then you set it from what the user did. Now you avoid the injection attack that way. They can no longer trick you into anything. Okay, and that's a way to repeatedly, again, use several parameters. So you see, you reuse a query template, but you change the value in there every time, right? Okay. That is just more things to scare you. Again, don't be too scared. Here, I'm just showing you how you generate the HTML. Do you see these angle brackets in there? Table, TR. Who recognizes HTML? So this is a program that's going to generate HTML. It's outputting TR is basically a row of an HTML table that appears on a table on the page. It's just iterating to create the actual display of a relational table. All right. And there, I continue to scare you with more code. This is an example with an API that is an alternative to SQL that works on, it's called SQL Alchemy. That's a Python library and so on. All right, but I scared you enough, right? And again, you really don't need to worry about that because this is totally out of scope. I just wanted for you to see how complex it can get, how dangerous it can get, SQL injection attacks, and so on. But now you have an idea of what it feels like when you actually create a website and interact with it. Whoever did this, maybe with PHP and SQL, or whoever created a website with a relational database? Some of you, right? Okay, so that's some of you might already have some experience with that. Okay, so I'm done scaring you with all of that computer code, but you get the idea, right? We have these 3 tiers. You connect to a web server. The web server connects to some business logic, so the actual program in Java or Python, which connects to the SQL database. The SQL database replies with a table. The Java program iterates on the rows of the table, generates the HTML, and the HTML is sent back to the user. Now you know the secret of what happens, and it will never be the same again. The next time you order a product on the internet, you will imagine all that's going on behind the scenes. Now it's no longer a secret for you. All right. Still have a few minutes to get into this new aspect of databases. It's called transactions and concurrency control. It's a fancy word for saying that typically you're not the only one using the database. That's basically what it means. If you're sitting in front of your Jupyter notebook solving the exercises, then you're the only one. But if you are an online shop with billions of people ordering products, then it's no longer to be the same because you have all of these queries happening at the same time, and you need to be very careful about what that means. And I'm going to give you an example with banks. There's 2 examples that are typically given, and I think in the book is the example of the bank where you transfer money from an account to an account. And there is the example of booking seats in an airplane and marking the seat as reserved. Why do we use these 2 examples? Because this is something that creates real life problems, right? If you mess up the account transfer, you might get debited of 1,000 francs from your accounts and it's lost. So that's a problem. And the other one is you book a seat on an airplane and it says, okay, that's booked, and then you arrive and there's no seat for you, right? So these are the consequences if you don't pay attention with transactions. This can have real life consequences. So this is why I'm going to tell you a bit about transactions and what that means, and also how concretely you can use them in PostgreSQL. So imagine that we have a bank. It's a very basic bank. Obviously, what I'm about to show you would never get a banking license in Switzerland, but just for the purpose of an example. So we have 3 customers. Albert has 1,000 francs. Alan has 2,000. Kurt has 3,000. And then Alice here is sending a SQL query in order to know, maybe she's a customer representative, and she asks, okay, you know, what's the account balance of Albert? And the PostgreSQL answers, well, it's 1,000, right? Then Bob here with another customer representative does the same. He says, okay, what's the balance of Albert? And he also gets 1,000, right? You agree with that, right? That's what the queries do on the table that you see. Now, Alice sends this query to PostgreSQL, update statements, set balance to 2,000, where name equals Albert. What's going to happen? What should I change in the table? Yes? Yeah, this changes, right? Now, Bob says this update statement set balance to 3,000 where name becomes Albert. What happens? $3,000, exactly. Now, Alice sends this query. I'm going to ask you 2 questions about that one. First, what does Alice think it will return? How much? 2,000, exactly. She believes that because she doesn't know about Bob. Bob is maybe in another room. But Alice had just set the balance to 2,000, and she expects to get the 2,000 back. but she gets 3,000. Something went wrong. And this is how Alice knows that there's other people using the system at the same time. Bob, however, gets, you can't see it because it's hidden behind the Zoom bar. Well, on Zoom, you can see it, and you will see it in the recording. What's written in there? 3,000, exactly. So for Bob, it's not a surprise, right? Bob just wrote 3,000. So what happened in here is that we had two people using the database at the same time. They both wrote to the database, and one of them won because he was the last one to actually write to the database. Now, obviously, we don't want that kind of things to happen because maybe the intent of Alice was to credit Albert with 1,000 francs and the intent of Bob was to credit with 2,000. So normally at the end, it should have been 4,000, right? So how do we deal with this? Well, there is a way to prevent these things from happening, but in order to prevent them from happening, you need to detect when they happen. And there is a way to actually detect. Now it involves a bit of drawing stuff. Basically, the idea is that you can try to detect the interferences, all kinds of interferences. For example, you can see that here it's order sensitive. Basically, I'm picking the first query by Alice and the second query by Bob. I'm saying the order matters here because in that case, we have first the query by Alice that returns 1,000 and then the query by Bob that writes 3,000. If the order were reversed, that first Bob executed that query setting it to 3,000 and then Alice executed the query select from where, then she wouldn't get 1,000, she would get 3,000. So it means the order is important. And in order to write down that this order is important, I'm putting a little arrow here that goes from that query to the other query saying, pay attention, the order is important. And we try to do it everywhere else. For example, there is also one here, right? The order between the first query by Bob and the updating query by Alice is also important because if you reverse the order and have Alice do it first, then Albert, then Bob would have Bob would have gotten 2,000 as a result and not 1,000. So we put this little arrow here to say that there is a dependency. What we did here has a name, it's called a read-write conflict, this little arrow. Read-write because it goes from a reading query, select from where, to an updating query, right? So far, so good? Everybody following? Who is following? Okay, and I'm going to continue to put arrows wherever I see these kind of things, right? So another example is write. Can anybody tell me where to put an arrow between two queries that modify the database here? Where should I put an arrow? Two queries that modify the database. Yes? These ones, right? Tell me what you thought, because let's consider it. Where would you have put an arrow? So let me try to show on the screen. So from this here to this one. Yeah. So you're absolutely correct that there is a dependency here. Technically, we do not put an arrow because it's implicit. Basically, we put arrows between the two because these are different people. And here there is, indeed, you're right that there is implicitly an arrow here and an arrow here because there is the order. But we just assume that the order in which we put them here is the intended order of the person, which is why we don't put it. But you're correct that it is indeed a dependency. It's only that we consider it implicit, right? All right. So let me put one here. Do you agree with this one? If I swap the order, then I'm going to get 2,000 here and here, right? So that also is important, this order. Then write read, I can also put from here to here. The order is also important. If I swap them, then I would get 2,000 here. And I also have from here to here that the order is also important, even though this one is in the middle and interferes, but there is this, right? And so now, let me remove all of that noise. Now we have basically put all of these arrows, these dependencies right here. And in fact, the way that typically you can have in the exercises is that I'm abstracting that like this, I'm basically going from the beginning, it's the time flowing, right? This is the beginning of time, the Big Bang of the universe, and this is going down here. So the first one I see is this one, then 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 this one. So I'm just going to go one after the other, top down. Alice reads from Albert Einstein, that's what it stands for, the Albert, right? So Alice reads R from Albert Einstein, then Bob reads from Albert Einstein, then Alice writes to the Albert Einstein record, then Bob writes to the Albert Einstein record, then Alice reads from the Albert Einstein record, and Bob reads from the Albert Einstein record. So the way we do that is with R's and W's. R is for reading, W is for writing. We put the name of it's called the transaction, but let's say it's people here, so Alice and Bob, we put in a subscript. And in the parentheses, we put the data being accessed. Here, it's always the same one. It's always Albert Einstein. So what we say is we have a schedule. It's the order in which some queries are executed, left to right, corresponding to top to down. For whom is that clear? Right? And so typically, in exercises, instead of giving you this, I'm giving you this. This is what you get. And we're asking you to then draw this and put the arrows there in order to deduce things. Right? So just as an example that you can try to work on offline in the next week, if now I give you this instead with three people, A, B, C, and two data records that are manipulated, alpha and beta, and you still have read and write, try to write them down like this as an offline exercise, try to reason on that and reproduce what I did here with A, B, and C, and put the arrows here like this. You can basically have exactly the same reasoning in order to reconstruct that. So try that as an online exercise. So you already have the solution in there, but try to just start with this. Just take this and try to reconstruct the schema here with the arrows as an exercise and see if you get the same thing as I do, right? That would be my kind of my homework on this, right? So I think this is enough for today. Next week, I'll continue with that, explaining to you how to detect, these conflicts. And then I'm going to tell you how concretely in SQL you can actually create transactions. This part will be the easy part, actually, in SQL. It's not so much to learn. All right. So thank you very much for coming today. Please do the exercises. Please read the book. I really, really promise you it's going to help to read the chapters of the book that I gave you. It's exam material, but it's really just the same thing I'm telling you in the lecture. Always helps to get several angles on the same thing. And solve the exercises. Again, it's the best way to get acquainted with the material. All right. There is a quiz released this afternoon that I think is graded, right? So if you didn't pass the 2 quizzes so far, you have one more chance to pass a second quiz. You need 2 quizzes out of 3 to get the bonus points. So now you have another chance to catch up if you didn't get one of the other quizzes. Thank you very much. Have a nice weekend. See you next week for the continuation. Thank you.